I love rationalizing denominators because radicals in the bottom of a fraction just straight up looks ugly. I don't really have another reason for wanting to do it other than lots of teachers require it. So here we go. The point is you're not allowed to have a radical on bottom. So how are you going to get rid of it? If it's just a regular radical, you're going to multiply the top and bottom of the fraction by it. In this case, you're going to multiply the top by root 7 and you're going to multiply the bottom by root 7. By multiplying the top and bottom by the same number, we're technically not changing the value here because anything over itself is 1. In any case, my new top is 6 times root 7. Can't simplify that anymore. And root 7 times root 7 is root 49, which is really just 7. That's totally a shortcut you should be willing to take. This is it. This is the rationalized denominator form because the radical is now on top and not on bottom. Capiche? Got it. You're also allowed to rewrite this as 6/7 of root 7. So this over 7 can build itself into the coefficient. Okay? Let's do it again, but for something that simplifies, I'm going to multiply the top and bottom by root 12 because that's what's on bottom of the fraction. I end up with 6 root 12 on top. I end up with root 12 times root 12, which gives me a whole 12. Yes. But now, in this case, the 6 and the 12 kind of cancel with each other. They're both whole numbers, and I'm allowed to cancel them. This divides by 6 to leave 1. This divides by 6 to leave 2. If you didn't know that 6/12 was 1/2, you need a checkup from the neck up. But the point is that the final answer here is root 12 over 2. And again, you're allowed to rewrite that as 1/2 of root 12, but most teachers are going to want you to stop right about there. Cool? Now, what if it is not just a radical on bottom? What if it is the sum of a whole number with a radical? Well, the answer is you're going to have to multiply by what's called the conjugate. The conjugate is the equivalent of this with the sign in between flipped. If there's a sign in front, like a negative, you're going to keep that, but it's the sign in between the number and radical that you flip to make the conjugate. What I mean by that is I'm going to multiply the top here by 3 minus root 2, and I'm going to multiply the bottom here by 3 minus root 2 as well. The reason we're going to do this is because this is now a difference of squares product, which will help us cancel the radical. You don't have to know that right now. You just have to trust that I know what I'm doing and it's going to work for you too. So multiplying 6 by each of these, 6 times 3 gives me 18. 6 times negative root 2 is minus 6 root 2. Nothing special there. Multiplying this product on bottom is going to blow your mind. You ready? 3 times 3 gives 9. 3 times negative root 2 gives me negative 3 root 2. Root 2 times 3 gives me plus 3 root 2. And root 2 times negative root 2 gives me minus a whole 2, because the roots cancel with each other when you're multiplying them. Now, what's important here is that because we strategically chose the conjugate, the two middle terms here, minus 3 root 2 and plus 3 root 2, cancel with each other. Negative 3 plus 3 is 0. These are gone. And you end up with, on top, 18 minus 6 root 2, and on bottom, 9 minus 2, which is 7. In hindsight, I may not have wanted to multiply this through there, because if this had been an even number of some kind, it might have canceled with the coefficients up here. That's not the case here, but this is my rationalized denominator nonetheless, because there's no radicals on bottom, and the only radicals are on top in the numerator, not the denominator. Shall we do it one more time with more canceling? Yes, we shall. What kind of teacher would I be if I didn't drown you in examples, right? How do you find the conjugate of the denominator? You take the exact same thing and you flip the sign in between. You're going to multiply the top by 7 plus root 3, and you're going to multiply the bottom by 7 plus root 3. The reason I'm writing in these extra brackets is that some teachers will nail you for not showing that it's this whole thing times this whole thing. If you leave off this outer set of brackets, it technically looks like just the root 3 is multiplying into the brackets. What can you do? You gotta be official, right? So let's multiply the top out. 5 times 7, 35. 5 times root 3 is plus 5 root 3. Root 3 times 7 is plus 7 root 3. And root 3 times root 3 is straight up 3. Yes, let's do it. Again on bottom, 7 times 7, 49. 7 times root 3 is plus 7 root 3. Negative root 3 times 7 is minus 7 root 3. Again, because we picked the conjugate, where these signs were flipped, the product of the outers and the inners cancel with each other. Plus 7 root 3 minus 7 root 3, we're going to cancel those right after I do negative root 3 times positive root 3. That's minus 3. These cancel as promised. What have I got on top? I've got 35 plus 3 is 38. And 5 root 3 plus 7 root 3 gives me 12 root 3. Did you notice how expertly I added those? The root 3's are both attached to coefficients, so I can add the coefficients. 49 minus 3 is 46. I got lucky here. I noticed that this is an even number, this is an even number, and this is an even number, which means you're going to be able to cancel them. You could factor it and then cancel the 2's, but I'm going to show you that you can just divide them all by 2, the same way you cancel out regular fractions. Dividing this by 2 leaves me with 19. Dividing this by 2 leaves me with 6. I've already divided the coefficient by 2, so I don't change the radical here. And I can divide this by 2, which leaves me with 23. My final answer is 19 plus 6 root 3 over 23. That's my fully simplified official answer to rationalizing the denominator on this. You should argue that this is a little simpler. We used to have sum divided by a difference, and now it's simply a sum divided by a whole number, which is arguably easier. Plus there's no radicals on bottom, so it's rationalized. Piece of cake. I hope you thought so. Try it on your own with whatever your homework questions are, and best of luck.